questions 13 and 14 should be fairly simple because I will give you the amounts. You have formulas, and I will give you the amounts in on your practice exam. We had to solve for the equilibrium quantity, but I will give you the equilibrium quantity and the equilibrium price for both of these questions. And the formula for consumer surplus is integrating from 0 to the equilibrium quantity, 4,000, the demand function minus the equilibrium price. And so that's here in this case, that's 200 minus 120, so that's 80. And so as long as you can keep the power rule for integration straight and distinct from the power rule for differentiation, this shouldn't be too difficult. If you have a constant term, you just add an x, and for any variable terms, you remember that this exponent is 1. You add 1 to that, so then the new exponent will be 2. But the reciprocal of 2 is 1/2, and so you multiply this coefficient times 1/2, and so 0.02 times 1/2 is 0.01. Then, here's your antiderivative. You evaluate that antiderivative at the upper limit, so you put a 4,000, in this case, in wherever you have an x. That's here and here. And then you just simply evaluate 4,000 squared times 0.01. You subtract that from 80 times 4,000. In this case, and in the case of the question on the final, the second term, the antiderivative evaluated at the lower limit is just going to be 0, because that lower limit is always going to be 0 for these questions. So this is just going to be 0. And so this is 160,000 divided by 0. So that's your final answer for number 13. That is the consumer surplus at a price level of equilibrium price of $120. For the producer surplus, there's just one more thing to remember. Again, we had to solve in the practice for the equilibrium quantity, and once again, you don't have to do that because I will just simply supply that. I will tell you what that is. And so for producer surplus, we subtract from the equilibrium price the supply function. And so in this case, that's 55 minus, and here's what we need to keep in mind. This is the extra bit for producer surplus. You'll have parentheses around the entire supply function. And so you will need to remember to distribute that negative, and it will be a negative, it will be a minus, across to each term. So this would be negative 15, this would be negative 0.01x, and this would be negative 0.003 x squared. 55 minus 15 is 40. And then from there, if you have distributed as you should, then the process is just the same as it is up here. You do have one more term, but just keeping that power rule in mind, this 40 will have an x on it, an x added to it, and then x to the first, 0.1 x to the first. The 1 plus 1 is 2, and the reciprocal of 2 is 1/2. You multiply 1/2 times 0.1, and that's 0.05. And of course, as I said, the exponent here is 2. For this term, add 1 to the 2, that's 3. The reciprocal of 3 is 1/3, and you multiply the 1/3 times this coefficient. 1/3 of 0.003 is 0.001. So now this is your antiderivative, 40x minus 0.05x squared minus 0.001x cubed. And once again, you evaluate that antiderivative at the equilibrium quantity, the right endpoint of the interval. And so that's just a matter of substituting the 100 in for wherever you've got an x. And when you do all those calculations, you get 2,500. And again, for for this integral, just as we did for this one, we're evaluating the left endpoint as 0, and that's just going to be 0 because each of these terms has an x in it, and you substitute the 0 in, and so this just comes out to 0. So this is 2,500 minus 0. So our producer surplus is 2,500. So that's the final answer for that question.